Hello, folks. So welcome to part 26 of Learning Rust series. And this is as part of my 100 Days of Rust series. And I'm on day 13. So in the previous video, like we were looking at vectors and like specifically this exercise, vectors, second exercise. And we learned about, say, iterating, mutation, and like we also, of course, learned about, say, map, filter, and then collect, take, right? As in we try to use it. I'm guessing there will also be things like, say, reduce. I don't know. Let's see. One dot dot filter or say reduce. Yep, reduce is there. I'm wondering what else is there. So any takes a closure, chain, compare. Nice. So cycle, interesting. Stopping on wow. Okay, so it goes in a cycle and like what else? There's also of course flat map, flatten and whatnot. So the interesting. Okay, there's even stuff like intersperse. I've never heard of that. It's this is a copy separated between. Okay, nice, cool. So oops. So now I'm just gonna go ahead and like check out what is the definition of these methods or functions. So it says, let's go and check out this one. It's a lot of, okay, creates an iterator which uses a closure to determine, I believe closure. So, I mean, I've heard of closures in JavaScript. You return a function from inside a function and like you capture data inside closures and whatnot, anonymous functions and stuff like that. So determine if an element should be yielded. Given an element, the closure must return true or false. The return iterator will yield only the elements for which the closure returns true. So if the closure returns true, it will pick it up, or else it will not. So 0, 1, 2. So here it's positive, so this will be false. True, true. So 1 and 2, right? Iterator x 1, 2, and then none. Awesome. Because the closure behavior takes a reference and many iterators iterate over references, leads to a possibly confusing situation where the type of the closure is a double reference. I didn't get that. Need 2 stars. Okay, I didn't get that. So, iterator, filter. Okay. So it's common to instead use destructuring of the argument to strip away one. So, okay. So instead you use, you know, reference so that you just have closure takes a reference. New iterators iterate over references. So this itself takes a reference. It's a reference to a reference. So yeah, interesting. And what else? Or both. Just do reference and then awesome. Note that is equivalent to find f. Okay. I'm not sure what is find. Filter f and find one element with the closure that no, wait. Let's go and find out what that is. One dot find. Okay. Such as for an element of an iterate that satisfies a predicate here. And return is a true or false. It takes at place of closure to each element, and if any of them return to the some element, if they all returns, all returns wrong. In other words, it will stop processing as soon as okay. Interesting. What is sum? I keep seeing sum. So let's see what that is, right? So let's check out filter itself. Note that is equal to this. Okay, stable, predicate, and like I'm guessing this is like the functions it takes the function mutation as iterator. I'm not sure what that is. Shell predicate p and then use a filter where cell size, okay, filter new predicate. Interesting. Filters and maps. Filter map. Okay. So, I mean, I think I can't understand these now. I'm gonna have to actually come back later when I understand stuff like where and then self size and whatnot, and what this kind of syntax means. I believe this is straightforward unsigned size, but I don't know what is an unsigned size. Like, what is it? What is the size? I get the unsigned, assuming U is unsigned. So anyways, with that, I'm gonna go ahead and like try out the next few exercises, next one exercise as part of this video. So let's run our Fastlinks watch, and we should reach vectors 2, and then you can remove this. I'm not done. Quiz parameters, vectors 2, also awesome, cool. Okay, awesome. So I've done that. So we have now moved semantics. So I believe this is for the ownership stuff. So you're moving the ownership from one. So cannot borrow vector 1 as mutable as it's not declared as mutable. Okay. So let's look at what's the thing here. Go here. So it says let vector 1 fill vector and then vector 0. Consider changing this to be mutable. You can't borrow as mutable because this is immutable vector. So you can't push or pop or whatever, right? So vector 0, new, fill vector, vector 0, fill vector. This is a mutable vector, yeah. And they've pushed things. Interesting. But you can't do this because this is a immutable one. And here also you can see that this is like an immutable thing, not a mutable thing, mutable reference. But here you say mute, and that doesn't accept it. And like, you can't do, wait, consider changing this. Wait, how come this got mutated? So this is a reference. Okay, so vectors, you get a reference. This got moved. So, and you returned it. Okay. And this got moved, and then you actually said it's a mutable reference now. You get created a mutable reference, and then you returned it back. This is a mutable reference. But I mean, this is a mutated thing, but this is an immutable reference. Mutated finally gives it back. The reference is here. You get back the ownership. You can't use vector 0 here after a guess because it has moved. Let's take a guess over here. Has then the vector 0, vector 0. Can I check it out? I think vector 0 should be invalid here. Yeah, borrow of moved value. So we moved the value from here to here. It's a reference, and the value got moved here. I mean, the ownership was moved. So now this is no longer valid. The ownership moved to this, and then it moved to this as a mutable thing, and then it was mutated, and then the ownership was returned here, and it goes here, right? So after this line, vector 0 is no longer valid. So move occurs because v as the type, it does not implement the copy trait. So if it does not implement the copy trait, it means it cannot be copied by value, like over the stack. So yeah, I mean, value moved here, so vector 1, so value borrowed here after move, right? Cool. So I'm going to go ahead and remove this one. I'm going to probably just do mutate. Let's see if it works out. Yep, it does. Awesome. So vector 1 has length 3, 22, 44, 66. So 22, 44, 66. And then 88. And then like, after you push, I mean, it's a mutable thing. But if it's immutable, like you don't have, if you don't do these, then it's fine, I think. Yeah. So, yep. Awesome. So I think that's all we can do in this, video. I'll probably do another video with another exercise. So that's all I had for this one. See you in the next one. Bye bye.